Hi, today let's talk about emission inequality. We know that global greenhouse gas emissions are too high, and you see here how many emissions we have pumped into the atmosphere since the Industrial Revolution, and you see the clear picture that you're familiar with, that there's quite some inequality between world regions, North America and Europe emitting historically the most, whereas, for example, Sub-Saharan Africa has not contributed much to the concentration of greenhouse gases in the atmosphere. And you see, compared to that, the remaining budget we have to meet our Paris global heating targets. So if we want to stay below 2%, then that's the amount of global emissions that was left in about 2022. And you have probably seen pictures and debates like that, who is responsible historically for emissions, which countries, and that is informative, but I want to make a crucial point here, which is, yes, there is inequality between emissions of countries, so country C, and we know that global emissions is the sum of emissions in different countries, and I write that as emissions on average times the number of people in a country. Now, so far we have assumed that there's average emissions in a country, right? But of course, within each country we have individuals, I label them, and they have different emission levels, and that's what I want to focus on today. Because global emissions is, yes, it's the sum over countries, but then the emissions per capita can be written as emissions per person, summed up over all persons in the country, divided by the number that gives you average emissions, and you see that these two cancel out, and then in the end you end up with the sum over all people in the world in different countries and their associated emission levels. And I want to know now how many emissions are coming from different countries. Yeah? So if I look at the global allocation of emissions, how much is coming from across country differences and how much is coming from differences within countries. And this picture already gives you a first idea. You see again here Sub-Saharan Africa, low emissions on average, East Asia, higher emissions, Europe, even higher emissions, and North America, quite high emissions on average. But what we'll focus on here today is also how these emissions are distributed within countries. So suppose a country has 100 people that live in the country, then I want to look at how many of the emissions are coming from the top 10% per person. Okay, so these are per person values. And then I want to ask, well, after I've looked at the top 10 persons in that country, how much is coming from the next 40% of the population? And then finally, the bottom 50%, let's not forget, this is like the half of the population that emits the least emissions in that country. And you see that those differences are quite drastic within countries. You see here in the United States, this is maybe the middle class, and you see that per person they emit way less than a person that is in the richest 10% or the most emitting 10% of the population. And you see that a relatively poor household in the US is emitting way less. And you see that pattern across all countries. What's also interesting is that if you look at East Asia, yes, on average they're emitting less than Europe. But if you look at the richest or most emitting 10%, they have surpassed even Europe, right? So there's a very rich upper class now in China or India or other countries that's emitting a substantial amount of greenhouse gas emissions. One other way to look at that is how much of emission inequality in the world comes from inequality between countries and how much is within countries. And you see in the 1990s, most of the differences in emissions in the world were driven by between country differences. So that means that in this formula, this term is the most important one. It's more important whether you were born in India or in Denmark or the Netherlands in the 1990s to account for emission inequalities than whether you're a high or a low emitter within any of those countries, right? So this was the dominant term back then, but you see the picture has dramatically changed, and between country differences have become way less important, whereas within country differences in emissions are now accounting for almost 2/3 of global greenhouse gas inequality. So it's mostly that we have to look at what's happening within countries and how emissions are distributed there, and not so much between countries nowadays. To show you the global picture, I made this graph where I'm now summarizing the whole world population into the global top 10% of emitters and the half of the world population that's emitting least, and the 40% that are in between. And here you see the tons of emissions on the vertical axis. We could say that on average in the world we're emitting about 5 tons of greenhouse gas emissions per year per head. And you see that's very unequally distributed, because if it would be equal, then each person, no matter in which decile they are, would emit roughly the same amount. But let's now look into this top 10%. Let's not forget the top 10%. Most people in Europe are in this global top 10%. But I want to zoom into those top 10% even more, and I want you to realize what's going on here on the vertical scale. If I now depict you the same picture, but not with the top 10%, but the top 1%, you see that the difference is becoming even larger. And now I'm going into the top 0.1%, and it's even larger. And if I zoom into the top 0.01%, you don't even see the other 90% of the global emission distribution anymore, because we're here at the level of about 2,500 tons per person, right? Which is way out of the picture of what the other parts of the population emit. Let me just walk you through that once more, that you see also the developments here in terms of the scale. Right, so it's really an enormous inequality of global emissions if you look at the top emitters and the bottom emitters. And the question that's remaining, of course, is how is that correlated with income patterns? And the data it's a bit tricky to do that, but some cool researchers have done that with data from Austria. So what you're seeing here is the income deciles. So this is the Austrian population. These are the poorest 10%. Those are the richest 10%. And then these are the 10% that are the second poorest, the third poorest, etc. Right? So each of those 10 categories represents 10% of the Austrian population lined up by income level. And you see, if you go from the poorest to the richest, you see quite a positive relationship, right? So it is true that the most emitting people in the world are also the richest. But what's interesting in my view is also the heterogeneity within income bins. So this would be the top 10% of Austrian income earners, and you see the top 10% on average, or on average emit about what is that, maybe 38 tons. But you also see here that there's quite some, these are box plots, this is within those 10%, these would be the 50%, and you see that there's quite some differences here, right? So there is a substantial amount of people in the top 10% that emit, say, well, 25 tons, whereas also some of the poorest households also emit 25 tons. And especially in the middle class, you would find also people that emit 25 tons, substantial amount of them, right? So this is about 25% of the middle fifth decile. Where does this come from? Well, some people may be very rich, but live in relatively small flats. Maybe they often take the train, they live in the city, so they don't have to have a car, they don't go on vacation with planes too much, etc. So they have a relatively modest emission lifestyle, whereas in some of the poorest households, you have people that are still in apartments, in flats, where they have very old heating systems that are very inefficient and emission intensive, right? So they're using old forms of energy. Or you have here in this decile, you very likely have people that own a car and live somewhere in a rural area and have to drive their car to work. And maybe if it's a couple, then maybe two of them have a car, right? Especially here in the middle class or in the fourth decile. Right, so there's an enormous heterogeneity, and that makes it difficult to design policies, because you could say, well, if the rich are on average emitting way more, then let's just put a carbon tax, but the carbon tax will hit those people at the bottom of the distribution also substantially. That's actually what this very interesting paper is about. That's unfortunate and makes policy quite difficult, because otherwise, we have an interesting picture. This is for France in 2019, and the thought experiment here is, what do we have to do to bring down the emissions in France down to the level that's consistent with the Paris Agreement? And you see that in the bottom 50%, they're already meeting the Paris Agreement, and in the next, the middle class, the middle 40%, well, yes, they have to reduce emissions, but that's an amount that's possible perhaps with technological progress, whereas the hugest adjustment has to take place for the top 10% if we would move to a society where emissions are equally distributed. So it's very interesting from the political economy point of view, I think, because here these people, they often, I think, vote against green transition policies and greenhouse gas reductions, even though many of them, or on average, they would not have to bring down emissions to meet the Paris Agreement, whereas we have green voters probably more likely here in this part of society that has to reduce emissions way more. I'm curious a bit where that's coming from. I'm also curious to read your comments about that question or the video below. Take care.